Hello everybody. Today I want to control the stepper motor using a HTTP endpoint on a ESP32 C3. We did most of it before. We did run a HTTP endpoint on the ESP32 a few episodes back using Picoserve. We're gonna use that again. We also drove a stepper motor before. But I want to combine it because I think all the integrations with Embassy really come together here. So what I did, I'm actually kind of struggling on how to organize the repositories because I'm always continuing on to older episodes, but I'm doing a bunch at the same time, and then I had to wait for hardware or whatever, so it kind of drives me crazy. So what I did, I created an API, a repository that just HTTP API that just is a hello world with a HTTP server on the ESP. So feel free to fork that if you want to do something like that. I'll try to keep it up to date. There are some. I did include some updates. There were some Embassy releases and also from Picoserve itself. So yeah, so this is just the bare bones HTTP API because I expect there's a lot of things that start from there, and also the whole boilerplate of getting the whole network stack to work is always the same. And yeah, it's hard to get right. So this is not something you want to do every single time. So what I ended up doing was create that API, and then I forked it. Well, I can't fork my own repos. I just found out, but I just copied it. I created a new one, stepper, and from there we're gonna continue. And then this repo will just do for these 1 or 2 episodes. Anyway, we have we have the Hello World application. So that's basically initiating the whole network stack. Then it has the web task that does instantiates this HTTP server. And there we basically create routes, in this case one route for the root, and we do a get to this function, and that returns anything that can be turned into a response, in this case just a string. And let's see if it actually works. We do a ESP flash. I don't really need to turn on the hardware camera because it's not gonna do anything physical. So yeah, so we can do a get to the root, and then it should say hello world. I have where is it? I have Postman. Well, it already did, but I do a get to. I'll do it from the command line for now. So we do a curl. Oh, it's not ready yet, I think. Oh, yeah, got the IP ready to go. I do a curl from this. It says hello world. So that's where we want to start. So where to begin? So we want to run the motor, right? First, we will need to create a task for that, right? So in the last episode, if you saw it, we controlled the motor by using an atomic integer. So what we did when we rotate the rotary controller, we had a knob we can rotate, and it would set that int, and the motor would monitor that int, and if it changes, it would move to that position. I don't really like that because it's shared mutable data, so it doesn't really scale. And what I want to do is that I create a motor task that runs, but to use a channel. And a channel is kind of a primitive in many async programming that on the one end you put something in, and the other end you get it out. So that we give that motor controller a channel, basically the receiving end of a channel, and we can just send commands to that motor to do something. So because that way we can split the sending of the messages and the receiving of the messages into two parts, and that makes it much more scalable and modular. So for example, if we want to control more than one motor, or we want to have different endpoint, that we can control the motor with a rotary knob or an API. That works really well with channels, and it gets kind of messy if you want to do it with shared state. So to get started, we will need to create a task for the motor, right? So let's see. Yeah, let's just get started. So we need to make an async function. Let's call it motor. Yeah, motor, why not? And we need to give it ownership of some pins. So let's call the first one is direction pin. It's pretty much the same as in the one with a rotary knob, something like that. It should be an output push pull, I think. Yeah, pin, and we have a step, and that's not 11, 1, GPIO 2, and that's with the output push pull as well. And need to import that, I suppose. Alright, what's it problem here? I don't see what's wrong here. Okay, yeah. And we need to import this one as well. Okay, so this should be able to drive the motor. So what we want to do in a nutshell, we need to add a channel. So it's like we receive move command. Well, first we have a big loop, right? We receive a move command. And then another loop, basically. Well, it's not really a loop, it's like a while not done, something like that. And then we do a step of the motor in the appropriate direction. So, but that doesn't compile, so let's remove it for now. So we need to give it a channel, and rather a receiver. And how the channels work is something like this. So I'll just put it in the main for now. Let motor channel is channel. Make sure you get the right one. MSC sync channel new. That's not gonna work out of the box because there are quite a lot of things that it needs. Let's give it that. So channel with things. The first thing is, if I'm not mistaken, the mutex, the type, and the size. Yes. So the mutex, I think we can get away with this one. Mention in the comments if we can't, but it seems to work. So we don't really need to use a mutex, an actual mutex here, because we're all running from the same thread. But I'm not entirely sure if for example, if you're using interrupts, if that's relevant. Now the second one is the command we're actually going to send through the channel. We don't have that yet. We're going to call that move command. I'll make it in a moment. And the last one is the size of the queue. So that's how many commands can stack. So yeah, it doesn't really matter a lot. But let's make a constant. I call it queue size. So we need to make the move command in the queue size. So you can put it here. Const queue size is queue size, I think. And let's call it 10. It does not matter much. And we have a move command. So we need to make a struct for that. What's a good spot? Doesn't really matter. Let's make it struct move command. And it has let's say distance, something like that. We move it in a certain direction and we use I32. So it can be positive or negative, and that's maps to clockwise or counterclockwise. So we made the channel, that works. If we're gonna run it into the executor really wants it to be guaranteed to be around. So for that, you see all the make static references sprinkled in. So let's make sure that we do that. So we can call the make static macro, and then yeah, we can do it. Let's do it in 2 steps. So I often do this, that I reuse the variable name, so it's not a mutation, it's just a new variable, and I put this one in here. So did it work out? Yeah, I think so. The macro just messes a little bit with the autocomplete, because now it doesn't know exactly which type it is. But it is a mutable, a static mutable borrow of the motor channel. So I think I can just put it in here. I'm not sure. Does that work? I did make the move command, right? Maybe I need to derive some things. Let's make sure it at least does like clone and debug or something like that. Huh, this is weird. I thought that would work. But in any case, we can just do our initial iteration, because that motor channel, that seemed to do the trick. So now we have a mutable borrow, and from that channel what we can do create a receiver, and we can create a sender. We can create multiple actually. So we can create as many senders as we want, and then we can send to that channel. We can also create as many receivers as we want, but bear in mind it's not a pub/sub channel, so that will mean that one of the recipients will get each message. It's kind of distributed, I guess, randomly between those. In this case we just need one receiver. So let's instantiate it for you for now. Let's call it receiver is motor. Why did I use an E here? That does not make sense. Motor channel dot receive. Does that work? Oh. Yeah, it is annoying with maybe I'll need to give it an explicit type because that it can't infer it, because it's kind of annoying that it cannot do it. Yeah, so we do a static immutable, because now at least we can see the type again. And I think then can we just do this now? Yes, better. So now we just have one statement to create a thing, and now the code completion works again. So we have a receiver, and we can pass that into our, oh, we didn't even call it yet. So we need to spawn our motor task. Motor direction and step, so it needs to get the pins. Do I still have pins here? I think io.pins.gpio gpio1 I think something to output into push pull output. Yeah, let's pin. Well, I'm not sure if they need to be mutable. So we take pin 1 and pin 2. Pin 1, pin 2. I'll unwrap it. So does this do the trick? Ah, yes, we need to add the annotation. Any embassy task needs this macro, and then you can call it like this. Okay, so that seems to be all right. Then we can we need to add our receiver, and that's a receiver future, I guess. And it needs the static, it needs the no up mutex, and it needs the q, the type, yeah, the move command, and the q size. Alright, so we can add, we can call it from here, so we do channel, motor channel dot receiver, and then what's wrong here? Oh, it shouldn't be a future. Receiver. Indeed, that one. And then we don't need this one here. So now we can have a receiver here. So that will look in the loop. It will look something like let command equals receiver dot receive and await. So now we have a move command, right? So we can yeah, whenever there's a command, we'll receive it here, and then we can do what we need to do to deal with that command. Alrighty, what is next? Let's go to the sender side, because the web task right now will need to send that command, right? So let's add the sender to the web task. Let's see here. Yeah, okay. So we go here to the web task, and we're going to add another one, and we call that sender. And I suppose that's the sender. No, not that one. That one. Static. No raw mutex move command and queue size. And then I guess we'll need to pass it to the handler as well. No, we need to do something more interesting here, because this web server, Picoserve, it is very similar to Axon, in a sense also Actix, but it works with so-called extractors. An extractor means that you can add parameters to your handler function to extract certain things. So for example, you can add an extractor to extract things from your request or from shared state. And in this case, we're gonna need shared state because the handler functions are gonna be very short-lived. So that looks something like this. So we have that sender function and we want to share that between all invocations of the handler, right? So we have this sender, and here we call serve on Picoserve, but we need to use another one, and we say serve with state. And if we do serve with state, we can supply state, and then once we do that, we can access that state from our handler functions. So now the last parameter should be the state. We can't just pass in the raw sender. Generally, you have a bit more elaborate data structure that embodies the state of your application. But right now, it's just about anything. And what we're interested in now is that sender, right? But we do need to make sure that we manage ownership. So for that, we need to create reference counting and a reference cell, so we have mutable access to it. So let's call it let state equals RC. Does that work? That one. New, and we put into that ref cell. New. And in that we put the sender. And we pass that in here. Is it? I think I need to borrow that. Yeah, that seemed to appease it. So I have now shared a reference counted reference cell, so we can get immutable access to that sender. So in our handler function, let's just modify this hello world. We can just add a so-called extractor, and that looks something like this. We do state, state. Now that's sender, doesn't really matter. And we use the state extractor from Picoserve, and then we need to describe what it looks like. So ref cell, and was it? Yeah, this is a bit of a beast of a type. Static, no raw mutex. Move command. So this is a prime candidate to do some type aliasing, because I guess I messed up something. Let's just create here just normal variable for a moment. Because I suppose I messed up some brackets. Yeah, okay. State sender, I suppose it doesn't really matter. So now we have a variable that is this whole thing, and that means that we can do sender dot send. Oh no, of course we need to borrow it first. Borrow, and we do a send, and then we can create a move command. Distance 1000 for now, and then we return hello world. Well, let's say command send, something like that. Right, so now anytime we hit this endpoint, we will send the move command through the channel, and the motor will receive it here, and then just do stuff. So, how are we gonna do stuff? I think what's the easiest way for now? At this point, I think we should start with just looping through the steps we need to take. So, first of all, let's check my notes. Yeah, let's start by see if we yeah, let's do a simple for loop for now. So we can take just the distance from it. So now we just have the distance. And let's do it this way. So if distance is, let's call it for now like a relative distance. So if it's a positive, we want to rotate clockwise, and otherwise counterclockwise. So if distance is greater than 0, then we set the direction pin set high. I need to be mutable, I think. And this one too. Set high, otherwise set low. Is this all happy? I guess. And then we just do a loop of the absolute value. So we do then for I don't think it matters, in 0 until distance dot absolute. So if it's 1000, it does this 1000 times. We do step, we do toggle. Is the type not correct? I think so that could be. There's something wrong with the editor. Let me restart it. Where were we? Here. It happens that somehow the Rust analyzer stops doing stuff. I have no idea what's wrong with it now. I mean, we can continue, but it's a little bit annoying. There is a problem. Yeah, that's just. Oh, it okay. Imported the wrong thing and that threw the whole thing off. Okay. So we need to import output, but not a standard thing, but a GPIO output. Alright, crisis averted. Fair enough. Unwrap it. Semicolon. I thought the editor was suspiciously quiet. Unwrap. So, and we need to pause a little bit. So after, I don't know, duration from let's do a half milli, something like that, and await it. What's wrong here? Yeah, we need to await it. That's a good point. So, yeah, the motor will just do a bunch of steps, one way or the other. In this case, always one. But we'll make that more refined later. Alright. I think that should do something. Alright, so I'm going to voice over for now, because it turns out that when I switch on my desk cam, the audio by default craps out. So sorry about that. I can't lip read, I don't remember verbatim what I was saying. But yeah, let's see what this does. So we're gonna go for the flash. That should not pose a problem. Alright, so go to curl. Let's see if we can call the endpoint and what happens then. So we curl to the root and it runs. It runs briefly, it runs pretty quickly, but you can see that it really does not ease in or ease out at all. So there's a very light propeller on it. So that works, but yeah, it is quite rough if it would be something heavier. So let's rotate some more. Yeah, it was clockwise now, so now let's see if we can move counterclockwise, maybe a little bit slower as well. So let's increase the weight. And yeah, so anyway, by the way, the boat propeller is just something to show that it's moving. Powering a propeller with a stepper motor would be weird. Alright, let's see. Start it up. And now it turns the other way. And a bit longer and a bit slower as expected. So that does everything we expected it would do. So yeah. It's pretty nice code. Like the motor controller code just doesn't really get more simple than that, right? We wait for a command and then we just loop until the command is done, and then we wait for a command again. We have the nice interface to just use the receiver, so it's completely uncoupled what the command is and where it comes from. So that's pretty nice. So I'm quite happy with this code. For the rest, yeah, sorry about this audio issue. I actually had to redo a few more episodes, and I will redo those completely. And yeah, hope you liked it anyway. Please give me a like. I can use it right now. And I hope to see you next time. Bye.